Ever wondered how scientists determine the concentration of a substance in a solution? Well, they have a secret weapon called redox titration. This nifty process, which involves a reduction-oxidation reaction, is a cornerstone of analytical chemistry. To get the full picture, we first need to understand what a redox reaction is. In essence, it's a type of chemical reaction where the oxidation states of atoms change. This change happens due to the transfer of electrons between chemical species. An atom or molecule that loses an electron is said to be oxidized, while one that gains an electron is said to be reduced. Now, onto the main event, redox titration. This process uses the concept of a redox reaction to determine the concentration of an unknown solution, often called the analyte. The first step of the process involves adding a solution of known concentration, known as the titrant, to the analyte. The next step is to add an indicator to the mixture. An indicator is a substance that changes color at a specific point in the titration, which is known as the end point. This color change is a signal that the analyte and titrant have reacted completely. To ensure a precise measurement, the titrant is added slowly to the analyte. This approach allows the scientist to stop adding the titrant as soon as the end point is reached, thus avoiding an excess of titrant in the solution. Once the end point is reached and the color change occurs, the volume of the titrant used is noted. This volume, along with the known concentration of the titrant and the stoichiometry of the reaction, is used to calculate the concentration of the analyte. The beauty of redox titration lies not just in its simplicity, but also in its wide range of applications. From water treatment plants to wine production, redox titration plays a critical role in understanding and controlling chemical reactions. In summary, redox titration is a powerful tool in the world of analytical chemistry. It involves a reduction-oxidation reaction, where a known solution is added to an unknown one, until a color change signals the endpoint. The volume of the known solution used is then used to calculate the concentration of the unknown solution. So the next time you see a scientist carefully adding one liquid to another, remember, they're not just mixing things up. They're using the power of redox titration to unravel the secrets of the universe, one drop at a time.